My name is Tony Hillerson. I will talk about source control management with Git. I say for the Android developer, there's not really anything that's Android specific in here, but since I'm an Android developer, I can answer interesting Android questions. I guess that's maybe enough to make it specific to the topic, but also feel free whenever you want to call out, ask some questions, anything you need to know. Hopefully it can get answered either by me or someone in the room or later after the conference is over. So I have worked with Android for a little while and Git for a little while as well. I've got a couple Android screencasts up with O'Reilly. Thinking about doing another one. So hopefully, I like that a lot better than books. Books are hard to write. Screencasts are hard to do, but not quite as hard as books. And I think it's a better way to learn, so I'm going to try to keep with that. But I have tech reviewed a few books on Android as well. And hopefully that qualifies me a little bit to talk here about anything related to Android that also relates to Git. One thing that the conference organizers want to is to make sure you rate the sessions. So either use the little blue guys out there. And if you don't have the conference app yet, here's the QR code to get it. If anybody needs to, go ahead and grab that. I'll wait until everybody's done. All right, cool. All right, so we're going to dive right in, right off the bat, and start working with Git. What I have up here is a terminal in Mac. Can everybody see what it says in the background? Up there at the top, at least. You'll probably see more up here in a little bit, but at least can you read that? Okay, cool. All right, I'm going to create an Android project here on the command line. I'm going to talk about the command line in a little bit, but everything is going to be pretty straightforward. So this is not like super high-level Android stuff. Okay, so what I'm going to do is from the command line create an Android project. The target of 27, which is ice cream sandwich with the Google editions. The name is going to be Google Android Test. The main activity is going to be Google Android Test main activity, and there will be a AnDevCon package. And once that is created, you can see all these files that you probably see in your Android projects. Pretty familiar stuff right there. So I've created an Android project that we now use Git on. If I go into that directory, what did I put that in? Oh, I put it right here. I was dumb. I'll go clean that out later. Anyway, I recreated the same project in a directory called AnDevCon. Okay, now I'm in that directory. So you can see all the Android manifest, the source, and the resources, and all those kind of directories that you're used to seeing. Just a simple Android project. What we're going to do now is make a Git repository that contains this stuff. Is when Git is installed, I can just say git init, and it will create a Git repository right here in this directory. I could then go on to put the files into the Git source control, but the first thing that I want to do is actually tell Git that there's some files that we don't want Git to know about. And if you would go to this is all in the slides, you don't have to go there now, but if you would go to github.com/github in the git ignore project, we'll talk about GitHub in a little bit too. They actually have a whole list of different git ignores for different types of projects. Here, if I go back, oops. Awesome, no internet. I'm going to need some internet. Okay, one more try. Okay, there we go. Git ignore project on GitHub. There is actually a Git repository full of a bunch of Git ignores for different types of projects. like if you want PHP or Clojure or ActionScript, you can find a kind of a stack git ignore. And what a git ignore any other source control projects like CVS or SVN, all of them have something like this. What it does is it tells the source control management system that there's some files that you don't want to put into source control. And that's a good place to start out. So we actually have one here for Android. I'm just going to grab this file raw. Not showing up on the screen very well. Mostly it's saying, hey, git ignore with an APK extension, ignore class files, ignore the bin in the gen directory, and ignore local properties. So this is a good thing to start off with so that if I'm checking in a project that Android's generated, there's some things already that I don't want to check in. So I'm going to start with that git ignore. Move that. Now I'm going to create a git ignore. With the contents of that file. And now I can use a command called git status, which will tell me, kind of hard to read. I don't know how to change that actually, so it's not even worth asking. How bad is it back there? It's kind of okay. Anyway, that's Android manifest and .properties. Those are all the files that we have. But since they're in red, those are files that are either changed or in this case, you see untracked up here. That means that Git knows that there's files that it doesn't yet really version or know about. But it won't at this point know of any files that, like in case like I did a quick build or something with Eclipse, so then a build directory would have been created, it wouldn't care about that. So that's why it's important to check in the git ignore first. So I have a bunch of files that Git knows it doesn't have versioned yet. And git ignore is one of them, and like I said, I want that to be in Git first. So what I'm going to do is do add .git ignore. Now if I do a git status again, you can see a file that Git knows is new. It's never seen this file before, and it's a change to be committed. That means it hasn't yet been committed. Now here's the first interesting thing, that if you're coming from another source control management system, about Git is Git has this extra idea that it calls the index, which is a place for you to stage up commits before you actually commit them. So it's like a staging area. You put these files on deck and then commit them. There's this extra step. And that's, we'll talk about why that's interesting and why it's useful to you further on in the talk, but keep that in mind. So that's one difference that we've already run into that's a little bit different about Git. Okay, so I have some changes to be committed and some untracked files. I'm going to make a commit now. A commit is like a step in my progression, my history of the project. So I'm going to make my first commit right now with the git ignore. So I issue a command called git commit, and it pops me into my editor, which happens to be Vim here, but you can configure it to be a different one. And I'm going to say, first of all, that I am committing git ignore. Okay. And you can see it gives me some other information like what we already saw in the status, so I know kind of what's going into the commit. I'm making this file is going to be checked in, these files are not, so that's useful information. Okay. Now I save that, and now I have a what it's saying up here is on this master branch, which we'll talk about in a little bit more, but think about just this is the main line of development on master. It says root commit. That means it's the first commit ever in this repository. It has this crazy number over here with 6 characters. At least it shows 6 characters. That's a unique identifier for that commit. And then it has my message, and it tells me what files changed. So I now have some history in my project. Now, I don't just have a bunch of source code that I can make changes to and maybe forget what changes I've made. I have some history that says, you started out here, you made this first change, and then we made some more changes, and then we know where development has come from, what bugs got fixed, all that kind of stuff. So that's a commit. Now we've made a commit in Git. If I clear off the screen and do another git status, you can see that, or maybe you can't see, but what you can't see is that those are the rest of the files that were generated. So now if I want to add the rest of those, knowing that Git will ignore certain files now that I've made that first commit with the git ignore, I can just say git add dot instead, which will add the current directory and all the subdirectories as well, which is also useful. And now if I do a git status, again, actually let me pop it up to the top. Now you can see the files in green as changes to be committed. And this is a very basic Android project. So once again, I've staged these files. They're ready to be committed, but they're not committed yet. So I can complete that with a commit. And I can use this -A option, which actually, if you're familiar with SVN, works sort of like SVN, where it just commits all the uncommitted changes as one commit. Then I don't have to pop into the, then I don't have to push things into the index with that option. And I can also use a -M option, which makes it a little easier. I don't have to go through the editor that it pops me in. I can put my command or my commit message right here on the command line. So committing act of atrocity, committing a new Android project. Okay, so now I have another commit. You can see this time, again, it's on the master branch, but this time it doesn't say the root commit. It says just the unique ID of this particular commit. And then a whole bunch of create mode messages, which basically said these are the first time these files were ever seen by Git, and now they're versioned. Now they're in source control. Now let's take a look back at history and see what we've done with the git log command. You can see that I have 2 commits in the repository. The first one, it has my information in it, which is nice, so I know who made the commit. It has the commit message. It has the unique identifier up here, except this is the full unique identifier, and we'll talk about that in a little bit. It's actually 40 characters long, and that uniquely identifies lots of different things in Git, but in these cases, the commits are uniquely identified by this 40-character string. And it says the date on which I committed it. So that's my log, that's my history of all the things that I've done so far in Git. Okay, so a lot of those things might have been a little bit confusing, it may be new to some of you, or it may be kind of translating across from something that you're used to, but I want to go through all these things first before we start talking about what Git is, so that everybody kind of has an understanding of what we've done so far and can relate back to it. So now let's talk a little bit more about what we've actually done. Okay, so one thing that you saw is that in Git, the workflow sort of goes like this. You start off from scratch, either with git init like we did. There's also another option, which is git clone, which will take a Git repository from some remote source and put it in a directory for me to start working with on my local machine. So I start off with one of those pieces. Then I make some changes. Whatever those changes are, either they're edits to files that Git knows about, new files that Git doesn't know about. And then I add those changes to the index, which gives me a place to stage up the commit. And then I commit it, and I get a commit object. And I do that until the money runs out, basically. That's the idea. That's the simple Git workflow. Basically, that's the thing that you'll be doing every day as you work with Git. Now a little bit about the git ignore. They can be nested deeply, so if you have a particular directory that has things to ignore that you don't want to ignore up the chain, you can put a git ignore down into that directory, and it'll act specifically to that to that directory in the tree underneath it. And again, remember, you can always go to github.com /github and /git ignore and find a whole bunch of useful ignores. Okay, git log, we saw that it shows us how to look at the project's history. It shows what got committed, the commit messages, the content that was committed, when and who did the commit. So if I pop back out here, whoa, it's just going crazy. This is one form of git log. This shows me a good sort of a good medium amount of information, not a whole bunch of information. But I can actually, git log is really powerful. It shows it has lots of different ways to configure what you see. So if I do git log -p, it shows me the contents of every commit as a unified diff format. So that I can say git tell me a whole lot of stuff, or if I do, actually let me show you a little bit. Now I have to kind of take a little sidetrack here to show you some configuration. So in your home directory, if you put a file called .gitconfig, or if you go through any of the Git configuration options, we can talk about that more later. I'm just kind of taking this sidetrack really quick to show you something more about log. Inside of that Git configuration file, the .gitconfig, you can put some aliases and useful stuff. You can see that I've got a file called gitconfig_safe because I have a version just for you guys to see that doesn't have my GitHub keys in it, which I don't want anybody else to see. So this is the version I can show people. Anyway, you can see here at the top, the user section is where I have all my information, and that's where it got the information to put into the commit, so it know that Tony Hillerson made this commit. And then I've aliased some things next. Some of these other things are interesting, and we can talk about those if you're interested later. But I want you to look under the alias section. That's where you can put little aliases to make it easier to type some of the Git commands. So I can say CO instead of checkout, CP instead of cherry pick, but also LOL, which is a lot of fun. I stole this one from somebody who works at GitHub called Scott Chacon. It's a alias for a really long git log incantation that makes a kind of really nice short one-line log. And so let's look at this one now. It translates to git log. The pretty format, which like pretty prints it, says stay on one line, and we wanted to abbreviate the commit and make a graph so that as things branches, you pop branches off and then merge them. You can see a graph of all those things and then decorate the commits. I'm not quite sure what that one means. But if we do get LOL, you can see here's a nice abbreviated format of what we've committed so far. Another thing to keep in mind now that git LOL, this pretty one line, gives me one extra bit of information about the commit, which is up at the top there. You can see head and master in parentheses. That's telling me that right now the master branch is pointed at that commit and head is pointed at that commit. We'll talk about those in a little bit, but that's kind of the power of git log. You can see what's going on in your repository a lot of different ways. Okay, now we're going to talk about remotes, because everything we've done so far, this should be of note to you as well. If you use SVN or CVS or something like that, or God help you, Perforce, something like those kinds of things, you have to have a server running. And everything that we've done so far has been all sorts of source control management type operations, and it hasn't gone anywhere off of my hard drive right here. So that's one extra interesting thing about Git that you may or may not have heard, but is also different from a lot of our source control management systems. It doesn't need to have a server. The concept of a server, it doesn't have a concept of a server. What it has is a concept of another remote repository. Everything that I can do with Git, I can do locally. But I can also share with other repositories that happen to be on another. It can be on a local area network. I can share over SSH. It can be on a server in the cloud, or whatever you want to call it, like GitHub, which is accessible through an HTTPS. But that remote, all it really is just another Git repository somewhere else. I've started repositories in the past where I wanted to share between my work computer and my home computer and just push them between each other with SSH, and that's a useful way of starting it. And then I can promote that later on to more of a team environment where we're sharing code through a Git repository that's at GitHub or something like that. And that is what that concept is called. What makes that a little bit different than other source control systems is that it's sort of called a distributed source control system. So if you've heard that Git is distributed, that's what it means. It doesn't have to have a server to work. And the concept of a remote is what sort of stands in, and you can have everybody working on your team on each of their individual machines, and everybody commits to one server, and it really kind of works just like any of the source control repositories or source control management systems you've used before, but it doesn't have to be that way. But it can. It's up to you guys, however you need to do it. I would say that's probably the most common use case still, because at your, wherever you're working right now, you probably don't have a lot of need to distribute things in a lot of different ways. You just have like one place where we're going to put the work on the product, and everybody's going to be merging into there, and then we'll release off of there. So there's no need to do anything crazy. But you do have that option with Git. So what I'm going to do really quickly is go over to if my machine will let me, please. There we go. I'm going to pull up my browser again and look at on GitHub. I've actually created a repository on GitHub called Git for Android at AnDevCon. And you can see it's giving me some instructions here, what my next steps might be. It says I should go create a local repository with Git init, and you've already seen that we've done that, and then add something to the repository. And then this last line right here, which I'm going to put up, once I can copy it into our terminal, is the next step to taking that local repository and pushing it up into a remote repository. And we can see it better if I paste it in here. Actually copy it. Okay, so what I'm saying is Git, I'm going to add a remote. Call the remote origin, which is kind of the standard name for the main remote repository in Git that you use, but you can use whatever you'd like. I could call that GitHub instead, and then have two remotes. Sometimes I push to GitHub, and at some other time, for some reason, I'll push to some other repository. This is the address, git@github.com:/T Hillerson. That's using the Git protocol, not the HTTP protocol, which sort of works over the web. That's all you really need to know there. And then it has the name of the repository at the end. So it doesn't really give me any feedback there, but if I do git remote, just git remote, it says that you have a remote called origin now, whereas I wouldn't before. I can do git remote show origin. And now it shows that I have a fetch URL and a push URL, and the head branch is unknown. Basically what let me just let me do this first. I'm going to push the changes up. I'm going to say, put all the commits that you don't have on the remote up on the remote. And I do that by saying git push origin master, which is the current branch that I'm on. You can see on my command line down at the end, in parentheses, it says master. That's the current branch that I'm on. We're going to talk about branches in a little bit. But basically this is saying, take all the changes that I don't have on the remote from my local machine and push them up there. So it does a whole bunch of work, gets this blob, sends it up to the server, and now I have, let me scroll this to the top if I can. And now I have a new branch called master on remote as well, whereas I didn't have anything in the repository before. And if I switch back to the web page that points at my repository here and reload it, you can see that now it doesn't have the setup stuff anymore. It has all of my files that I've committed. And not only that, I can go and look at all the commits that I've done. I committed to git ignore, committed a new Android project. I see that I have one branch called master, and this is all now available for someone else to clone. If I go back here to files, I think it might have the instructions for cloning. I would just basically copy this and then say git clone instead of git init, and git clone with that address at the end, and it will copy it into a directory. Pull it all down, and they can use, on a different machine, they could do all the, whatever they wanted to do with the Android project. Okay, so that's the concept of a remote. Some of the things you can do with the remote, add as many remotes as you'd like. You can clone from a remote, and that will automatically set up the origin remote usually. That'll be the one that it picks up. You can fetch the remote. I say git fetch origin, for instance. That will give me all the changes that are on the remote that are not on my local machine. but it won't actually put them on any of my branches yet. So there's 2 steps involved. Get me all the changes, and then merge, where it puts those changes onto my whatever branch I happen to be working on. A pull is a fetch and then a merge. So if I say get pull origin master, then that will pull down all the changes for origin and merge them into my master branch. So now I'll have all the changes that somebody's made to the remote repository and pushed up. Push, you've already seen push. That's where you take the changes that are not on the remote from the local and push them up. So those are fairly, I mean, it just involves basically putting code up somewhere where the code doesn't exist yet, or pulling code down where the code doesn't exist locally yet. That's what you do with remotes. One other thing that you might want to keep note of is the idea of tagging, which is kind of the same as in other source control management systems. If I want to kind of give a name to a commit, like, hey, this was version 1, I want everybody to remember that this is when we cut off a build for version 1 and deployed to the Android market. If I tag a certain commit with a line that looks like that, then I can call it version 1 from then on. And then I can push that up with git push -- tags. And each tag can also be cryptologically signed so that everybody who uses that repository will know if it was tampered with, which is important in some use cases. Okay, so simple commands that we've seen so far. Init will create a repository, add will add files, conversely remove, or RM will remove files from version control. Commit will take changes that are in the index and make a commit object of those to the local repository. Excuse me. Log will give you a view into that history that you've created with commits, and tag will let you name a commit, something a little more interesting than those really long characters. And git ignore tells Git to ignore certain files. So that's kind of a really, like the fundamentals that you'll need to use every day if you're working with Git. Now let's take a little bit of a step back and ask ourselves why we care about source control. So I think that for the solo developer is where you might wonder the most, why would I care about source control? But really what it is protection against mistakes and the freedom to experiment and then try different things without worrying about, because if you didn't have source control and you wanted to try something new, I suppose you could, well, if you make a bunch of changes, then how are you going to back those out if you didn't like the direction you were going? Well, I guess you could copy it over to another directory or something like that, but then you've got to figure out which one you're going to maintain after that. It just doesn't make any sense, and it's so easy to use source control that you might as well, because you know you're going to go down a different path and try something and not like where you went, or maybe like parts of it and want to use parts of it. But source control gives you the freedom to do that and the ability to do that without a bunch of hassle. And since Git is so easy to use and it doesn't require a server, it's really good for someone in a solo situation. I think that everybody should be using it. Just start out using it before you know you need it, and then when you do need it, you'll be really happy. And then there's a lot more obvious reasons that for a team of developers that source control management is important. You want them to pursue parallel lines of development. I want this team to work on these features, I want this team to work on these features, and I don't want them stepping on each other when they want to share code with each other. Or at the very least, the kind of the default thing that people think about source control is that it's kind of like a backup system in the cloud or something. It certainly does that. But at some point you want to get all those different changes together, and some source control will help you work with that and understand who's making what changes and really manage the code as the code base instead of just a bunch of files that are going to run at some point on some device. So hopefully that's convincing. Who I really want to convince to use source control. If you're not, is anybody not using source control? Maybe we should ask that first. All right, I'm preaching to the choir. Just move on. Okay, so now we've got a really simple Git controlled project. Let's talk a little bit about how to get set up and a little bit more of the history of Git and things like that. Okay, so this is what Git means. It was created by Linus Torvalds and he says that he's kind of an egotistical bastard. That's the way how he describes himself. And he names all of his projects after himself. So Linux was named after himself, and Git was named after himself as more of a description. By himself, of course. A more, I guess, descriptive answer to what is Git is it's free, it's open source, it's a distributed version control system. We've seen a little bit of what that means. It's designed to handle any size of project, and it's designed to be very fast. If you have a Mac, you can get set up. I recommend using Homebrew, which is a package management system for Mac. But if you're using Mac ports or something like that, you can get through either one of those. Or you could just install it from source, but I really recommend using some sort of package management system instead, and Homebrew is the best out there. On Windows, you want to use msysGit, which will give you kind of the Unix type environment. So you'll be able to use a shell, kind of like you've seen me using today. And getting set up on Linux, you probably know what to do already, but you can use something like apt and get it there. I'm not going to talk a whole lot about GUIs today. If you have questions about what I like or don't like about some of them, we can talk about that afterwards, but here are quickly a couple links to some graphical user interfaces you might want to use instead of the command line. I really like Brother Bard's GitX fork for all the Mac people. That's the one that I use. And if you're familiar with Tortoise SVN on Windows, then there's a Tortoise Git as well. I think that basically works the same way. Integration with Explorer and stuff. And if you use Eclipse, then there's something called eGit, which you can use that I think is good. I don't know. I never use it. But it's out there. Check it out. To find out more about Git, you can go to the official website, which is git-scm.org. There is a Creative Commons licensed book called ProGit from one of the people that works at GitHub named Scott Chacon. If you can ever hear Scott Chacon speak about Git, there's this awesome presentation called Smacking Git Around that he does, where he just like rapid fire goes through, I don't know, a couple hundred slides of little tricks that you can do in Git, and he's going so fast so that it's more of an experience than a learning experience. Whoa, it's awesome to see, like, if you can pick up here and there what he's actually doing. There's a lot more to Git that you can do than just source control management, and Scott Chacon knows all that stuff. He also has a video up on the Pragmatic Programmer's website, which will be kind of an introduction to and a kind of in-depth look at how to use GitHub, which you probably will be running into if you haven't already run into it. Check out both of those. Okay, and one last thing. This is kind of more in line with the GUI slide, I guess, but the command line. So who here thinks that the command line is sort of legacy and has been replaced by graphical interfaces? Okay, cool. So I'm preaching the choir on that one too. It's not the old way of doing things on computer. It's a different way of doing things on computers. Instead of pointing and clicking at things that you want, like caveman-like, I want this. You're speaking to your computer. It's a more expressive way of dealing with your computer. It's not outdated. It's just different. It's a different way of interacting with it. It's fast. It's faster than digging into menus and stuff. There's really a lot of good reasons to use the command line. When I talk about Git, I always use the command line. I don't use a GUI so that people understand what's going on underneath, and because that's important. And as you learn about Git, I recommend using the command line. Even if you're on Windows, the stuff with msysGit will get you set up to do all the command line things that you've seen so far, and many others. I think it's important to start out understanding what you can do on the command line and then move to the GUI. I use a GUI for some things. It's just simpler for some things, but for a lot of things it's not. So I recommend starting out with the command line. All right, let's talk about what goes on inside Git. And now we'll kind of go over some of the things that we've seen already but may not have understood. First off is these big old chunks of characters that, as I've said, are the unique identifiers of commits, but they also end up being unique identifiers for a lot of different things in Git. What it is a SHA-1 hash. That's secure hashing algorithm 1, because there's other ones besides number 1. That's a cryptological hash that basically takes a whole bunch of content and produces a fixed length string of characters that uniquely, I guess, describes or sort of is a digest of that content. So that you put the same content in, you will always get the same hash out, and it will always be the same length, 40 characters. That's interesting in cryptology because you can get a digest of the message and say that this message hasn't been changed if I compare it to another one, and it's more secure. It's really, really, really very unlikely that you'll be able to go from a SHA-1 hash and figure out what the content was. You would have to produce a whole bunch of content and check. You'd need a whole bunch of computing power. There's more secure versions of other hashing algorithms. I think there's a SHA-3 maybe. I don't know. Maybe just 2. I don't know. I'm over my head here, but that's not really the upside for Git. What the upside for Git is that you can take a whole bunch of content, like, hey, here's all these Android files that I just checked in, and I can come up with a unique identifier for what went into that commit. And it's also very unique, so since you always get the same content, or you always get the same SHA-1 hash from the same content, I can uniquely identify things in Git, and as people are checking things in from all over the world, I don't have to worry about a collision where a unique identifier is referring to a different commit which has different stuff in it. And here's a little quote from Scott Chacon about how unique it actually is. So to have a probability of a SHA-1 hash collision rise to 1/2, you need about 10 to the 24th objects, which is probably bigger than you can have in your repository. So you don't have to worry about that. Now let's talk about what goes into Git, what Git actually works with. So in Git, this is a little bit of an oversimplification, but think about Git this way, and it'll get you pretty far. In Git, there are only blobs, trees, and commits. So let's talk about what those are. Blobs are just like if you come from the database world where a blob type is a binary large object. It's just a big chunk of binary data. And these are all the contents of your files, and Git stores them in the Git database, which is in your repository directory. There's a file called .git, or a directory called .git. And inside there is a directory called objects, and that's where it stores all the objects that have ever been and are now in files that are in your working copy. But it's really efficient. That sounds like it's inefficient, but it is really efficient because there's been a lot of work done in this area. Excuse me. I don't talk to people a lot. It's really efficient at storing files in this way. If there's a change to a file, it'll have a different representation of that file in the database. But if there wasn't a change to anything else, then it will just point back to the files, to the data that it already has. And it's also really good at compression. It's really good at, like you can check out a huge, long, couple-year history project from GitHub, and it'll come down, less than a minute. And that's not the same case with SVN. And each blob is also uniquely identified by a SHA-1 hash. You'll see this pattern over again. SHA-1 hash is the unique identifier for everything. You can check out blob contents if you want to dig into Git or .git/objects and pick out a file. You can do git show and the file name, which will be the SHA-1 hash, and it'll tell you what is in that file. And again, that's uniquely identified. That means there'll never be a commit with that identity. There will never be another blob with that identity that doesn't have the same content, and so on. Okay, next of blobs in the hierarchy are trees. Trees give structure to blobs, and they're also objects. They're identified by SHA-1 hash. And you can view a tree like using the command lstree. What a tree is. This is for more like playing around. But as you start to understand what Git's about, you should go ahead and check these kind of exploratory commands out a little bit, just so you can see what's going on in there. Okay, now above trees are commits. Commits are, again, identified by SHA-1 hashes. A commit points to one tree. There's a message that's attached to the commit. You need a message, and it could have a parent commit, and it may have more than one parent commits. But in one case, unless it's a dangling commit, which is a commit that's sort of not referenced and can be garbage collected or thrown away, just like it should make sense to you. But the initial commit of the project also doesn't have a parent commit. But commits could have more than one parent commit if they're merged from two different other commits, which happens a lot. You can see all the reachable commits. The concept of a reachable commit is something that's important in Git, because that means that those changes are in your history and should be accessible from the commit that you're on. If you use the command git rev list from a commit or a tree, it will show you all the reachable commits from that point. Refs are something that I didn't list in my 3, but they really are understandable in terms of commits. They're pointers to commits. So you've seen me using this head word all over the place. Head is a ref, and a ref points to a commit. And head is defined as the most recent commit on the branch that we're currently checked out as. So head will always be the latest commit wherever you are. If you change branches, then it'll be the latest commit on that branch. And those are all stored in .git refs heads. Okay, so now for the more visually inclined, let's go through it the visual way. Blobs are content. They're sort of floating around, stuff in them. And they each have their SHA-1 hash identifying them. But trees give the blob structure. You can see here those blobs, they point to files. They have the contents of files, at least at a certain point. And also trees can point to other trees. So it's kind of starting to look like a file system, right? That's a fundamental difference about Git too. So if you come from the standpoint of, hey, we're going to make a source control system. We've got a bunch of source, and we want to have a history of everything. What would be a smart thing to do? Let's take all the changes that have been made. This change came after this change, and here's the change that came after this one, and here's the change that fixed this bug. And that's what something like SVN does. And it sounds smart because you're only storing what changed. But what Git does, it's a little bit different because, and Linus probably, he tackled the problem this way because he's a file system guy, so he thinks about things in terms of file systems. What he said is we don't want a list of changes because you can't just pick out any change about the file system from that point. You've got to go backwards and then construct from the beginning to know actually what's in the file system at that point. Why don't we instead have a series of snapshots of a file system? And if we can do that efficiently, which it does, even more efficiently than SVN stores the list of patches, what you've got is a way to easily know, here's what's in the file system at any given point in time. And look back up the history, that's what the file system is. Because what it really is like a whole directory of directories. It's just like a file system. Here's the file system at this point, all the contents of the file system stored efficiently. And here's all the contents of the file system. So it has a really efficient way of storing everything that was in the project from history back into from wherever you are right now into where the project started out as. So that's a fundamental difference, and that gives Git a lot of different power because a lot of different powerful things that it can do because it knows you're working with a file system anyway. So what Git is giving you is a bunch of snapshots of the file system instead of a bunch of patches. So anyhow, and trees are basically like directories. And then commits point to trees. So that's how you have a history of the file system looked at. Or what the file system looked like. This commit had this tree, which had these blobs in this tree, blobs in this tree, and then the commit that came before that, because commits have parents, had this tree, which had these blobs, which had these trees, and so forth, and so on and so forth. That's how Git stores everything. And then it gives you refs, which are nice, easy ways to refer to commits, like head, which is the most recent one. And that's pretty much all you need to know about Git to understand how it works, mostly. But it's good enough for definitely our purposes. And if you think about things that way, you think about, well, shoot, I've got myself in this situation now where I've got a bad commit in there. what do I do? How can I get in and fix that? We're going to go through some more commands that let you do some more interesting sort of surgical things on your repository. But as long as you keep on remembering that all a commit is nothing magical. It's a pointer to a tree, which is a file system. This is everything that was in the file system at that given point in time. Okay, so let's talk about some of the more interesting things that you could do with Git. Okay, the first one that is kind of unique to Git, because Git itself is unique, is the ability to interactively add files. And this concept down here is important to what you can do with Git. It's sort of a fundamental way of working with your code, is the idea of a semantic commit. It's just like you want to have, in like good object-oriented design, you want to have a class that has a certain responsibility, and when it starts to gain extra responsibilities, that's a bad code smell, because this thing, we're no longer sure what it does very well. What does it do really well? It should do one thing and do it well, kind of. That's sort of general heuristic to building classes. The same thing should be said about commits. This commit should be about something. That's what we mean when we say a semantic commit. This commit should be fixing this bug, or adding this feature, or somehow stepping up to adding the feature. It shouldn't be like, I made a bunch of changes. That's not what a commit should be. It's not a big truck, right? They'll just dump changes on it. And interactive add and Git's index will help you do that, right? So we've already seen in the first sort of little walkthrough there, Git add will take some changes and put them into the index. You haven't actually made a commit yet, but you're building up to a commit, because the commit comes out of the index. It doesn't come out of the working changes in your local directory. Git commit A will bypass that index, so that's something else you can do if you know all these changes are to the point of one commit. But git add-I is a useful command line tool that will allow you to look at all the changes and look at all the new files and pick out, like, I want this file, I want the changes to this file, I want part of the changes to this file, because part of the changes to this file are kind of for some other reason. Like, maybe I had made some changes to the header, and I also changed the license copyright date or something like that. I don't want those to be in the same commit. I want the copyright one to be about, I changed something about the copyright date. So I can go back in the history and see, well, here's where we worked on the copyright, not here's where I made changes to the header. So I put the username up in the header or something like that, and I changed the copyright. I want to pull just the username change out and add that to the index and leave the changes to the rest of the file in the working copy. So that's what Git in the index allows you to do, and Git add interactive is the way that you can do that. And this is definitely the command line version. I'm not going to go through right now because we're running, we're right on time. But I can show you this type of thing later. But this is, it's not bad on the command line, but this is something I usually use a graphical client for, pulling out, like, I want this file, I want this file, I want this part of this file. Put that in the index, make a commit, and I'll go back and do another commit. So basically, I'll go through and work and not think about source control because I don't have to, and then come back and say, well, what are all the changes that I made? And break off different commits that mean something particular so that someone can go back and understand. And Git interactive add is one nice feature of Git that will let you do that. Now, what if I make a mistake? If I've made a commit in SVN, then I have to make another commit that says, oh, sorry, that last one was screwed up, and make sure everybody's got the latest, right? But with Git, you can do something called amending a commit. So I can say git commit -- amend, and it will pop me back into my editor and take any changes with me as if it was a new commit, but it changes the last commit on the stack. So if I just didn't like the message that I put in, I can change it with git commit amend. The old commit goes away, and now I've got the new message that I want. Say I forgot to add some files, because this is one common mistake that people will make because of the index thing with Git. If you have files that are untracked that Git doesn't know about, and you have some changes that Git does know about, and I do something like git commit -a, which will bypass the index and just make me a commit with all the changes, but I forgot to add that new file, because Git won't deal with that new file. And I say, oh crap, I forgot to add that new file. Just do git commit dash, or add the file, do git commit dash dash amend, and now I've got a commit that's exactly the way I want it to be. Sorry, or if you just realize that the last commit that you created had a bug in it or something, git commit amend is your friend. The problem is if you've pushed these changes already to another remote, it's not impossible, but it's bad form to just amend the commit and then try to push it back again and say, hey everybody, I hope you didn't get the last one because this one's right. Git will first of all say, hey, you're trying to push refs that don't exist anymore. That means you did some tinkering here, and I'm not cool with that because it wants everything to be straight in the repository. So basically, you can force it. You can say, okay, I want to push this commit that I've created on mine that orphaned the commit that was wrong, and so now everybody's machine, if they pull down the changes, they have that commit that was wrong. And if you force your changes to orphan that commit, you're changing things that people may already know about the repository. So the right thing to do is say, hey, everybody, I made a mistake. Here's a new commit that fixes the last commit. So if you check back to that point in history, it's wrong, but that point in history is still there because they may already know it's there. Does everybody understand that I explained that well enough? So once you've pushed some changes, do not use git commit amend. It's just bad form, although it is possible. What you want to use instead is probably something like git revert. It's kind of more like git reverse because what it does is commits the exact opposite, like the complement of the patch of another commit. So I have some commit, 5 commits back in history that we now know is wrong, or maybe we just want to change it. It was like a temporary change or something. We want to commit the reverse of that change. We want to make it go back to the way it was before. Git revert, and then a particular commit will take the contents of that, invert the patch sort of, and make a new commit with the inverted patch. So that's the way to back out a change, basically. It's not the same as SVN revert, if anybody uses SVN. SVN revert is more like git reset, which we'll look at in a little bit. Git stash is pretty cool. Basically what it is, I could show an example about this too if we have some time later. But basically, like I'm working along, here's the use case for git stash. I'm working, I'm right in the middle of some hard problem. The boss calls, holy crap, the website's screwed up, you got to fix it right now or you lose your job. So you're like, well, what am I going to do with these changes that I'm in the middle of? Because it was a hard problem, I don't want to forget where I was or lose my work. I could copy those files out or something like that. But with Git, I can use something called git stash. I just say git stash, and all those changes, all the working copy modifications will be stored in this sort of side repository, not as a commit. It actually will be a commit, but it's not actually going to be in my history. And then I go fix the problem, push the changes, get it on the servers, everybody's happy again now. And I can just say git stash apply, and it will copy those changes onto my working copy. Or I can say git stash pop, and it'll take them off of the stash. And then, so in the former case, I would still have them in the stash. So I can kind of keep around some changes. In fact, I use that a lot on this recent project I was on for Android, where I had to give builds to the client really frequently, but I had to change some things about where it was pointing to, like point to the production server instead of this development server or something like that. And also change the stinking map key, which is something we always forget. So I just had a stash where I would say apply the stash, now I'm in production mode, do the build, and now get rid of those changes, and I could keep using the stash instead of having to figure out what the changes were every time. So it's like a little side repository that hangs off of your repository. It's not shared to other people's, like you can't push the stash to other people's, but it's really useful for those types of use cases. And for all these things, get help from the command line will give you some more information and probably some examples too. Some of the help entries are a little obtuse, but some of them are actually helpful. Yep, so that's git stash. Now let's talk about branching. Branching is a really important concept in all source control, but with Git, because Git makes it so easy to branch, you should be using it all the time. And it sort of, for a lot of people, sort of fundamentally changes the way they do development because it gives you the ability to easily branch. Has anybody branched in SVN? Now, how useful do you find it? Do you use it all the time? Like, what do you use it for? Like really big operations where it's like, okay, for many months now, we're going to have people work on this branch, and they'll never see the changes from the other branch at any point in time until we decide to figure out in the manual how to do a merge in SVN, because nobody knows how. I don't, at least. I mean, without screwing something up. Branching in Git is basically writing 40 characters to a file. It's not copying over this whole other directory into some other magical directory just because that's the way people do it. Apparently it's gotten better. I don't know, I'm back. It's not, SVN branching is not anywhere near as simple as it should be. Git branching is basically writing 40 characters to a file, because all it is saying, here's another commit that points to this working tree, whereas since we don't have that commit on this branch, it's just not, those changes aren't going to show up. And then we can make a bunch of changes to history and at some point bring them over to this other branch. And it's so easy that, like this is a quote that I found on the web. It's like hitting save before you fight the level boss. You want to hit save because you don't want to go back to the beginning of the game when the boss inevitably beats you. So branching is sort of like that. So you branch by saying git checkout -b, and it'll make a new branch. And then you can work as if you were on the master branch, which is nothing special really, it's just another branch. And you can continue to work as long as you want. And at some point you can merge those changes into another branch like master and then push them up for other people to share. Or you can push that branch up for other people to share. Or you can keep that branch local and then just keep it up to date by rebasing. I'm going to go through these things in a little bit. But the point is that if I want to do something, I want to sort of try something out. Let's say maybe we're maintaining an Android app that is probably not going to see ice cream sandwich. So you're not going to be able to use any of the cool features. But what if I want to try them out? Well, I'll make a branch and try some things out. And I can completely just blow those things away and not worry about the changes, but still learn something about my code. Or maybe they're useful, I don't know. But branching allows you the ability to make those decisions not at the source code level, but at the change level. Like here's my repository. I'm thinking about things as a bunch of different changes that I can apply or not apply. It's easy to do those types of things when you're branching. So here's some concepts. The main line, people usually talk about the main line. That's where most likely something is going to come out of to go to the market or go to production, depending on what type of project you're working on. That's usually master in Git. It doesn't have to be because master is nothing special. But you decide on your team what you want master to be. On web projects, so there's kind of a fundamental difference between web-type projects where something is deployed and Android-type projects or desktop apps or something like that where you have releases instead because you can't go back and maintain what somebody has on their computer, basically. You have to either get them to install an update, something like that. Whereas a web project, everybody's pointing to the only resource. You can think about it fundamentally differently. Usually on web projects, what you do is have master in the shops that I think are doing it the right way, they have master always deployable. I should be able to put what's in master on the server right now and nobody's going to have any problem. So then they do all the more tricky stuff, either as teams or as individuals on branches. And then when it comes time to merge those changes in, then there's quality control and that type of stuff to make sure that those changes are all something that you want to be deployable, but master is always deployable. You can sort of think about things that way for your Android app if you want, or you can think about more in terms of this is version 1 and here's version 2 and I'm going to be maintaining some version 2 stuff, but here's my free app and here's my paid app. I want to maintain the changes for the paid app on a different branch. Those are all possible things that you could do. The concept of a topic branch is something that you could get into your workflow on your team that you're working on. Basically, it's a branch for doing something. It's where you get it's sort of like the same concept of a semantic commit brought to the next level. This branch is only about implementing this feature, or this branch is about fixing this bug. And so you cut off the branch, you do your work, and then it gets merged back in, and everybody can see that that branch is about, if you want to, it's like an IRC channel. Like if you hop in here, we're talking about this topic. Everybody fix this bug or whatever, if there's people collaborating. That's what a topic branch is about. And it's so easy, you probably shouldn't be doing any work when when master is, if you have that little command line thing like I have that says I'm on master, you probably shouldn't be doing any work. Although you can be, and then you can move it over to a branch with some stuff that I'll show you. So topic branches are a really good concept that Git makes really, really easy to do. You should be doing them. I kind of already talked about this, got a little ahead of myself there, but some branching strategy. Think about that a little bit when you're going to be using Git for your team or introducing it back to your team. What do you want master to mean? How do you want to use these different branches? So let's look at branching visually a little bit. So up on the top, the lighter blue, I have the master branch. And at some point I say git checkout -b add login activity. And now I have another branch of development with the commits here. And the parent of this commit happens to be on this branch. So and the parent of that commit is this one. So all of these changes are available to the code as a link. Does that make sense to everybody? That's how branching should look to you, kind of in your head. And then at some point, when we're done with adding a login activity, then we can switch back to the master branch with git checkout master, and then git merge, the branch you want to merge in, git merge add login activity. And even though in this case there was another commit that happened on the master branch that wasn't originally available to all of this code, as I'm doing this work, I never have these changes unless I do something special. But at some point then I merge them in, and now all of these commits are up here and back onto the master branch, and then head is pointing here, and all of the changes are available to everybody that we've made on the master branch. That's the idea of branching and merging. There's another concept, because Git is a little different, and that's the concept of rebasing. So let's say I have master branch, and at some point, just like in the last example, this guy shows up. There's this other commit that's now available on master that's not available to this branch. What I can do is a rebase. I say git rebase master on the branch of add login activity, takes the whole history, and now moves it so that the parent tip of the master branch instead of something in the middle of the master branch. And now these changes are available when I'm working on this branch. And that is you should only do that when you have not pushed your branch to a remote repository, because that's dealing with the history, and there could be some problems if you push things up. So if you push, you could be orphaning commits on people's history, and you don't want to do that. So if you've pushed your branch to the remote repository, you can't really use rebase very easily anymore. But it's okay, you can use merge instead to get changes that are on the master branch, for instance, into your branch. But you can always override it with git push force. It's just not something I recommend. Rebasing is not just for branching, though. If you have changes that you're pulling down from the server, and those sort of touch changes that you have locally, then Git needs to do a merge, just like any other source control management system would need to do. So some commits are coming down and they need to be merged in. What you can do instead is say, everything that I have locally that I don't have on the server yet, pop that off the stack, apply all the changes coming down, and then put my stuff on the top and do any merging locally. And that's it's a lot more clean. So you can do git pull rebase instead. That's something that I usually do. But because Git doesn't have two parents to merge, it only has one parent to merge, it can't do as good of a job of merging. So sometimes it runs into problems, and I just have to start over and just do a regular pull instead. So that's something that you might need to do. But yeah, I recommend using git pull rebase when you can, because it keeps things a little bit cleaner. Another cool thing that you can do with Git is called cherry pick. So let's say I have this history here, and I want this change. I want to add this change, which was a really important change, to master, but I don't want the rest of that branch yet, but I just want this particular one. So I can cherry pick that commit, and what happens is Git will create a new commit Not the same commit. It doesn't just put a reference to the commit, but it takes the contents of the commit and makes a new commit with those contents on the branch. And that's for that type of a use case, when I just want to grab some important change instead of making it myself. And that commit should reply cleanly during the branches because it's the same thing. One other fancy thing you can do with Git is the interactive rebase. What that will actually do, you say git rebase -I for interactive on a commit, and it will give you the history up from the current head to that commit as a list of, like, here's the unique identifiers, here's the messages. What you can do is reorder those commits, or say at one point I want to squash these 3 commits into one commit, or I want to pop out of the rebase, the interactive rebase, and actually change this commit because it was wrong. You can do all sorts of different things during the interactive rebase. And then Git will go back and replay those things for you, maybe popping out to let you make some changes or something like that. And then all of a sudden the history is different. And that's a really powerful thing that you can do in Git because of the way that Git's structured. Again, don't do this after you've pushed changes unless you really know what you're doing. So probably don't do it. But it's pretty powerful. And then there's a couple different ways to fix problems that you may have accidentally created. Git checkout for a file name will remove all the unstaged changes to a file. So I just want to start over. It'll just, you do git checkout in the file name and it'll get rid of your changes. Sometimes that's useful to do. Git reset will allow you to basically make your working copy and or index look like something. So here's some examples. If I say git reset in a file name, it will unadd it. So it'll take it out of the index. Git reset head will do that same thing, but to all the changes that I have. Git reset head with a caret, or you can use, there's a whole language of these things that you can do. Caret means 2 commits before the current commit. Caret means like 1 commit before head. Tilde means 1 commit before head. It's another way of doing it. You can say tilde 42 if it'll be 42 commits before the head. So if I say git reset head tilde 42, it will pop everything off the whole history stack 42 commits back. And that's one way to change a bunch of things. And these are all examples of a mixed reset, and I'll talk about what that means right now. First of all, let's talk about a soft reset. So git reset soft will move head. Reset always moves head. So remember that. It moves head to the particular commit that you want. Then it moves all the changes that were in the commits that it just got rid of into the index. That's what soft does. So it's basically like, I didn't like those commits, let me try it again. Move head back, and then give me all those changes on the index so I can recommit. Git reset mixed builds on what soft does. So it moves head to a commit, puts all the popped changes into the index, and then moves all of the index to the working tree. So that's the next step that it takes. You can see it's kind of getting one step more complex there. Git reset hard builds on what mixed does. It moves head to a commit, takes all the changes, puts them on the index, takes all the index changes, puts them on the working tree, and then makes the working tree look like the index, which effectively blows away all those changes. So git reset hard is destructive. Measure twice, cut once with reset hard. Like, know what the heck you're doing before you do reset hard. But there's still use cases for doing all of these things. For instance, git reset head caret 1 will basically say, I want to do that one over again. And remember, you can also do something similar with git commit amend, but like with git commit amend, like say I forgot a file, I want to add that to the commit, I can amend that. But if I accidentally committed something I didn't want to commit, then I could do git reset head caret, and it will pop that off. I make the changes to the index, get rid of that file that I didn't want to commit, and then make a commit that is in the right way. It's in the right shape. Now git reset hard, when do you ever want to completely blow away a whole bunch of changes? Let's say I made 5 changes on the master branch and then realized, oh, why am I doing this on the master? I should have done this on a topic branch. So I can what I can do is do git checkout B, git checkout -B to create a branch that points at where head is pointing at. So now I have a reference to all those commits which refer to each other, so they're not orphaned. and then I go back to master, and I say git reset head caret or tilde5 or something, and it blows away all of those from master, and now master is where I want it to be. It doesn't have those changes, and now they're effectively pointed to by the branch only, so now I can continue on as if I started off the right way with the topic branch. Does that make sense? And all this is possible because all those commits you think about commits, not a bunch of patches, right? Okay, so that's a whole bunch of stuff that I threw at you there. But the take home of this talk is that source control management is important even if you're not working in a team. No matter what kind of no matter what kind of a developer you are, whether you're working in a team, whether you're working on web projects, Android projects, simple HTML projects, you should be using source control. Git is fundamentally different from other source control management systems because of some of the reasons that we talked about. It's not just a big database of patches. It's actually a snapshot, a series of snapshots of the file system, and that makes it really powerful. It gives you the freedom to innovate, to make mistakes, and to collaborate with people on different remotes. And but you don't have to, which is also really powerful. So you can use it even if you're just a one-man shop. And then later on, push all that stuff up to remote and share with people and collaborate. But I think you should be using Git for all these reasons. And if you have any questions, we can talk about them now. So I have a Git course that I put up on a service called Udemy. If you'd like, you can, I have embedded in this, I have the link and also a coupon code that you can use to get half off right now. And you can get these slides over on the right there by checking out that QR code, which should be an URL to the slides. Here's information about where you can get more information about the stuff that I've done here. And thank you. Do you have any questions? Let's talk about them now. We can stick around. I think the lightning talks are not until 4:45, so we have like 15 minutes to, you can come up with some examples, we can kick it around a little bit, but okay, one question back there.
Yeah, how does Git work with continuous integration?
It works fine. So I'm sorry, the question was how does Git work with continuous integration? It works just like any other source control management system, but you could, I think maybe where you're going with the question is you could have CI work off of like a particular branch or something if you wanted. So then it would basically check out all the changes to the repository and switch to the branch or something like that. That's an extra interesting thing that you could do with continuous integration. We use Hudson a lot, and we just set it up to pull changes from Git. So it like every 15 minutes, it'll check if there's anything new and then pull it down and build off of that.
Is it easy to set up a server, the Git server?
Question was it easy to set up a Git server? There's a couple different options. I don't know if it's, I wouldn't call it easy, I guess. There's not like a one-click installer out there. Most of the options are something like you need to have your own a Git repository on the server, but then you provide access somehow. So you could just do it over SSH. If you have a machine out there that you can let everybody have SSH access to, you can just let them say git clone and then SSH username, the path to the repository, and they can use it just like that. That's pretty easy. But if you want it available over the web with like HTTPS or something, then you set it up. There's a couple different ways to set up, and like with an Apache front end or something. GitHub also has an enterprise version, which they just released. It's probably more pricey, but you can install like a whole version of GitHub inside your firewall. That's another option that's available, which is also pretty useful, because then you don't just have people do like topic branches. You can have them work in separate Git repositories and then do the whole GitHub forking thing. So I fork this repository, do what I want, and then I can submit a pull request, and we can talk more about that. I'll give you a tour of GitHub. Question back here?
Yeah, thanks very much for your presentation. It's been a bit of a black art that I've been trying to dive into, so you made it really very quickly.
Good, thanks.
A couple questions that I have, though. One is, it seems to me that the issue of synchronizing the different branches back for a merge still takes, I'm expecting a lot of manual effort. Like, you change the file, I change the file, we want to put it back into the master, build it together. We both rely on the same library, the same header file that one of us has changed.
Right. Well, so the answer is that, yeah, that problem exists. Git doesn't solve that problem better than other source control management systems. In fact, early on, Git has a system of strategies that it can use during a merge, and you can apply different strategies. Like you can say, merge in this branch, and whenever there's a conflict, pick theirs, or pick ours. Like you can put different strategies in, but the default strategy is mostly like other source control management systems. If there's really close changes, it'll say, no, there's a conflict. You're gonna have to figure it out yourself.
So it will highlight this conflict.
Yep. It basically leaves. It doesn't do the ours and theirs things like SVN does, but it leaves you it puts patches into the file, or it puts not a patch, but something that looks sort of like, here's a big chunk that came off of that branch, and here's a big chunk that came off of your branch. You decide what's right, because. In fact, earlier on in Git's history, it was even dumber about merges because that was a design decision that Linus made, because basically he said every merge is potentially broken. It doesn't matter if it applied cleanly by a simple diff type of an algorithm. Like somebody may have done something conceptually incompatible with this branch. So you should always have to go through and look at the changes. But since then, it's a little bit easier to work with it, and it's basically probably just like SVN. You got to pop the file open and look at the chunks of changes and say, or you can use like a diff tool and say which things should be merged which way.
The other question I had is, in your presentation, you also used console. And I know some of your aliases. I'm wondering, are those available on the device slides?
All the command. No, I didn't do that. Sorry.
Okay.
You can buy this, and I have. Sorry, I'm trying not to shill it. I didn't do that for this presentation. No. I like being scared and living on the edge with live coding in front of people. One question back here.
Could you talk about why you might choose to rebase a branch as opposed to just merging the tip of the branch to the main?
For anybody who didn't hear that, he's basically asking why you would choose to, or when you would choose to remerge, or when you would choose to rebase instead of a merge. I would always choose to rebase unless I'd push the branch to another remote, because rebasing it keeps history cleaner, because it's not a bunch of merges along the way. Every time I pull in changes, it pops my stuff up and puts it on the top of the stack and lets me deal with any conflicts or even changes in a much cleaner way.
So so you have a branch with the history, and you rebase basically from the beginning of the branch, right? So it goes in each one of the revisions now.
No, not necessarily from the beginning of the. No, you're right. From the beginning of the branch. So it basically takes the branch, 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 branch,